And welcome to the Daily Space Weather Show. Let us know in the comments if you think we ought to start bringing it back to a live format instead of a premiere with recorded videos. Tell us what you think. We're always interested in what our viewers have to say here at the Smash News Network, least busted name in news. That's the past 24 hours. And we've had a big decline in things like sunspot number, the radio flux, the X-ray output. Even the likelihood of coronal mass ejections has gone down a little bit, but there are still plenty of plasma filaments on the Earth-facing side of the disk. The most active sunspot, or T-mass, is this group down in the southwestern limb. We rotated the field of view there to keep it stationary, and there was a little oversight. We kind of caught the edge of it there. Sorry about that. There's 304 angstroms, the equatorial zoom. Yeah, most likely place for a large solar flare remains in that southwestern limb. The southwestern quadrant, I'll say. It's not quite on the limb yet. That is our T-mass, our most active sunspot. And let's, we'll look at, there's 131 angstroms also for today, April 28th. New volcano appearing on the list. Let's briefly take a look at that. And earthquakes, the Tofua volcano. Tofua volcano, located in the Tonga Islands. Looks like an interesting island there with a likely estuarial lake. A saltwater lake, probably that is, I would suspect, due to its extremely close proximity to the shoreline. But of course there is no real scale there, so who knows what the distance could possibly be. Probably estuarial. Also Shivaluch producing an explosive eruption there, and Ibu. 16,000-foot ash plume there from Ibu. Luatobe, Semeru, also Dakono, like I said, Tofua. A new eruption commenced there. No ash or gas reported yet. Popocatépetl, sporadic emissions there. Fuego, Nevado del Ruiz, Sangay and Revenador, both in the nation of Ecuador, and Sabancaya exploding in Peru. As far as earthquakes go, a couple 5 magnitude events for the past 24 hours. For example, Eritrea had a 5.0. That northeastern African country. And besides that, Tonga had a 5.2. That was at extreme depth. 168.2 kilometers there for that one. And what else do you got? What else do you got? Pardon my scrolling. I try to smoothly scroll so you can see where I'm scrolling. And that's where the earthquakes end. So just a couple 5 magnitude events. The radio flux is now all the way down to 140, I think it is. 140 solar flux units. So there is the past 1 year. It's this black line here. And yeah, the next update will see that decline to 140 solar flux units. NOAA's not forecasting any geomagnetic storms. Just a little geomagnetic unrest tonight, and that could be showing up at any point. Not sure why, and interestingly enough, their Enlil spiral actually shows a CME impact way out on May 1st into May 2nd. So, not sure what that's all about. Maybe they're forecasting a CME that didn't happen yet. It doesn't look like a coronal hole high-speed stream, so I don't know. I don't know what's up with that, NOAA. What's up with that, NOAA? Drop us a line in the comments. National Oceanic and Atmospheric Administration. As far as ESA, who's been in agreement with us lately, ESA looks like it hasn't updated for a while, but But there are some humps happening there also. So just a density increase, but no velocity increase. That's just kind of weird. All right. They're saying that velocity will decrease. All right. Well, anyway, there's ESA's data. That's ESA's Enlil spiral. That's their forecast. Some huge CMEs there looking like they'll miss Earth, according to ESA's model. So here are the past 4 hours of Earth's magnetic moment from space. The Geospace Magnetosphere movie is based on the space weather modeling framework. If you want to read about it, go to the Geospace Magnetosphere movies page, scroll to the bottom, and click details. There'll be a link to the space weather modeling framework. You can download the software yourself if you like. Here's Earth's magnetic moment from the ground, our Geospace ground magnetic perturbations map. It's depicting changes to Earth's B field, Geospace delta B. The units of that are nanotesla, its magnetic flux density. So yeah, things are geomagnetically calm on planet Earth. KP 0.67. Again, very much geomagnetically calm conditions. Solar wind is weak. The ACE is only measuring about 1.5 to 2.5 protons per cubic centimeter. Slightly elevated velocity there at 466 kilometers per second. The Discover showing a little denser solar wind there at about 8.3 protons per cubic centimeter. Still elevated solar wind speed there, 473 kilometers per second. The rest of that is unremarkable. GOES magnetometers are unremarkable. The heliosphere magnetism is next, and Earth is in a small South Pole-oriented sector. That will only last another day or so. Might be in a North Pole sector once again by tomorrow's Daily Space Weather video. Make sure you stay tuned for that. You wouldn't want to not know what magnetic sector of the heliosphere Earth is located in, right? So here are all of the sun's magnetic fields, the photosphere, the polar fields, and the solar B field, all depicted at once for the past 4 days. Which brings us to coronal holes. So we've got a mixed bag on the Earth side of the disk, a mixed bag. Both North and South Pole-oriented coronal holes. And yes, there are channels that claim that coronal holes can somehow forecast earthquakes. I guess it's because they've never looked at the data together, because it doesn't correlate. So people keep claiming they're forecasting earthquakes with coronal holes, and I guess it's cute when it's not grifting, but it is grifting, so it's not that cute. It's kind of pathetic. And I mean, it's just, I don't know what to say. It's, a guy says a thing, sounds confidently, and then whether the thing's nonsense or not might not matter. He was so confident that people just believed it, no matter how ridiculous the claim might have been, and no matter how not backed up by the data the claim might have happened to have been. So let's take a look at coronal holes from SDO. Yeah, so there are North and South Pole-oriented coronal holes there. I'm not going to really worry about illustrating the polarity of them because, well, right there's the data. So yeah, those are South Pole coronal holes though. Those equatorial ones, those are like fingerling coronal holes from the South Pole coronal hole at the North heliographic pole. So the top of your screen, those are South Pole oriented coronal holes. Which brings us to sunspots. The number keeps dropping. It's dropping down toward 100, folks. So make sure that you have your bunker timeshare all ready, so that you're able to get into the bunker when the sunspot number drops and remind the people who are frightened of an active sun that it's now time for them to get back out of the bunker, because we're going into an inactive few days or a week or something like that, right? Every time the sunspot number drops, people are like, they were right, we got to get in the bunker because there aren't enough sunspots. It's bonkers. Bonkers for bunkers. Their dudes have gone bonkers for bunkers. So let's see, what do you got? Flare probability. It's mainly from 3654. That is our T-mass and will remain our T-mass likely into tomorrow. Before we get to that, let's show sunspots from the ever popular perspective. The highly in demand Solar Dynamics Observatory. So a little bit of growth on those central disk sunspots, and then a little bit of degradation on those central disk sunspots. We should see a dip in sunspot number once again yesterday, as there are many, many groups setting in the west. So we'll probably drop below 100 sunspots. Again, at that point, all of you low sunspot number is scary people should definitely get in your bunker timeshares at that point. So here we've rotated the field of view to sort of make those features remain stationary so you can sort of see how they evolve a little bit more easily. Again, that is our most active sunspot, our most likely place for a large solar flare. We'll also show the magnetic fields on that same zoom, 30 frames per second, SDO HMI instrument. So there are some areas there where you can see some black and white very close by. Those are the high magnetic shear regions. And south hemisphere sunspots are typically led by South Pole-oriented umbrae, which is what you see there. So South Pole umbrae there are in black, North Pole umbrae are in white. And that means it's time for things like flares and energetic particles. So let's see what we got. We've got something. Goes proton flux. Ain't got nothing. And flares, we've only had C-class intensifications in the past 24 hours. There were 2 M-class events yesterday. We didn't cover them. I was all tied up with shift cables. And before we do that, it's time to show the 94 angstroms wavelength. There you go. Dear God. That's pretty sweet. And next is the solar system forecast. So there's where things lie today. That's where things will be in 1 week, as Mercury speeds away to catch up and blow past Venus once again. Next, our star chart. This is what's on the sky overhead. It's the sun chasing Venus to the horizon. And by the way, if you're up before dawn, you may see the rising of the moon, then Saturn, then Mars, then Mercury, then Venus, all fairly equally spaced out there, southeast of the ecliptic. Also, of course, you've got the summer triangle up there now, Deneb very high in the sky, the tail of the swan in the constellation Cygnus. Right up there, just circling Polaris all day, every day. Next, astronomy photo of the day, which is a ring nebula. Now that might look small, but that is actually a light year in diameter, that central ring. And that is a composite image with the Hubble, some binocular telescope, and it's a composite. There's a bunch of different images there. That stellar nebula, a bunch of emissions from the central star, capturing red light emitted by hydrogen as well as visible and other infrared spectra. The Ring Nebula, or M57, 57th entry in the Messier catalog. So some great features there. It is believed to be a planetary nebula. There should be some planets orbiting that central star. Again, that is an entire light year in diameter, so that is quite a large region. Of course, things in space can be very deceptive when there is no reference point. Splentacular. Now let's look for CMEs in the home neighborhood. And we didn't cover it yesterday, so let us know in the comments if we missed any CMEs. I don't know. It looks like from the forecast we didn't miss any. At least any earthly directed ones. So things have been pretty calm here for the past 24 hours. That's 67 frames from George Mason University. Here are some wow, that's still loading. That's jacked. Is the stereo A loaded at least? All right, stereo A has half the day. That's all right. All right, what do you got, stereo A? There's a difference imagery. Couple CMEs there. One showing up early this morning, really originating late last night. More of an ongoing stream. Doesn't look too exciting, but let's see what's going on from our perspective with our synced imagery. Oh, it's so good. So good. So there are the past 24 hours. And there may be some earthly directed ejecta in there. As we zoom in a little closer, we do see some shenanigans around the center of the disk. These could be plasma eruptions. What do you got? There may be some earthly directed ejecta in there. I would say there probably is. So yeah, expect that to arrive May 1st. And that's looking like another agreement with actually NOAA this time. So we'll see if ESA also upgrades. We're seeing a filament eruption south of that sunspot. This sunspot right here, whatever its number is. I refuse to memorize sunspot numbers. And yeah, there are some, perhaps some ejecta in there. I think there probably are. I'll say 75% chance for a CME impact there. A stealthy one. A stealthy one. We'll see if we see any filaments vanishing. By the way, those videos come from helioviewer.org. Let's move on to filaments. Yes, filaments. They're a thing. So this is Big Bear this time, as that was the most recently updated ground-based National Sunspot Observatory Hydrogen Alpha telescope. Yeah, let's switch to the color imagery instead. Now, do we see any filaments going away? Now, that's not, if you don't see a filament going away, that's not a guarantee that there wasn't a CME. Sometimes you see coronal mass ejections happen with no visible filaments. Yeah, maybe not. I'll give it a 50-50 chance. Looks like the Larry David filament's still intact as well, which is ahead of that sunspot. It's this arching filament right in this area, just to the west of that large sunspot group. Anyway, moving on to bonus features, but first the past couple of hours, and we do see some activity from that same sunspot, the T-mass, the most active sunspot group, that group down there in the southwestern quadrant. Bonus features are starting with charging hazards. We ain't got none. The electron flux here is up off the floor following some activity, multiple CME impacts. And there is the 1-year graph. The electron flux is rebounding to moderate levels, we would suspect, and it looks like NOAA agrees with a few days of an uptick in the relativistic electrons. Next, the layer where it's measured, the F layer. And things are looking nominal there as well. We'll show the anomaly graph just so you can understand the anomaly in megahertz from a 30-day median. So there you have that. A little bit of low frequency anomaly there showing up. Perhaps a little more than you might have expected. Global Ionosphere Nowcast is next. I had GPS errors on Friday. What about you? It caused me to ride off course on a group cycling ride. Twice. Don't worry, I caught back up. But yeah, there's our total electron content and maximum usable radio frequency. And the anomalies for both of those. The Global Ionosphere Nowcast, or WHAM, whole atmosphere model. And we're having some very slow server difficulties. Not sure if that's on our end. Screw it, we're skipping to meteorology. But first, press the like button if you enjoy the content. Again, let us know if you'd prefer the content to be live. We may switch to a live format and just stop recording videos entirely. It could be a thing, might not be, I don't know. But it's a consideration, so let us know what you think in the comments. Press like. If you're new to the channel, press subscribe. Otherwise, you won't get the world's most comprehensive daily space weather content delivered directly to your YouTube subscription feed. Meteorology is first, and check it out. We've got a very spooky thing going on, a possible 666 there in the Pacific Ocean. Look at that. 3 low pressure zones in a triangle. Everybody knows triangles in things like weather and nature are very scary and spooky. So beware of the northwestern Pacific. It may be cursed. It may have the sign of the beast appearing in low pressure zones, which could be HAARP clouds. Maybe it's chemtrails. Maybe it's cloud seeding. Maybe it's solar radiation management. Maybe it's Scope X. Maybe it's Operation Popeye, or maybe it's Operation Paperclip, or some other thing that's been unclassified. Oh no, oh dear God. Those are the surface winds of the eastern world. Those are the jet streams. Jet streams of the central world, shown here. Surface winds shown here. A strong wind out of the east into the central Mediterranean whips across. Some strong winds on Lake Michigan and Lake Superior also, otherwise known as Gitchigumi. Those are the surface winds of the west, and there are the jet streams. Satellite imagery is next. It's our NASA GOES Interactive Weather Satellite Suite Visible Satellite. Oh, look how good it is. Brazil. It's got some stagnant air in the troposphere there, causing clouds to evaporate and reform and evaporate and reform. A sign of atmospheric stagnation and a humidity at those tropospheric levels very close to dew point. We've got severe thunderstorms and tornado warnings in effect in some places, so make sure you heed those. This is Witty.com's thunderstorm warning map. That's one of the ways you could follow these sorts of things. And check it out, some very bad stuff going on in Texas and Arkansas. So weather.gov also has a bunch of warnings there, both for flooding as well as, again, tornadoes, flash floods. So weather.gov is where to get those. If your location is lit, those are too many counties for us to cover on the video. But we will show some tropical tidbits forecasts for your viewing pleasure. TropicalTidbits.com is where we get these forecasts from. They are just a GFS 72-hour model. So there's pressure and precipitation for the next 3 days. And severe weather threat will continue for the Gulf states, as you can see. Some of those systems are going to move due east. Some of them are going to kind of make a turn to the south. Here is total accumulated precip, and look at that. Arkansas is going to be more than moist, also Louisiana. But especially Arkansas, there will be places with 5 inches of rain. 72-hour GFS total accumulated precipitation forecast in inches. is what we are showing here, yeah? Next, diesen ist the GFS accumulated positive snow depth change forecast in inches, yeah? And yeah, there's going to be some significant snow, but it's mostly in Canada. Alberta's going to have some areas there getting well over a foot. As May begins with snow also in Montana and Idaho, Wyoming. And anyway, there's the map. Accumulated snow depth change, positive snow depth change in inches. Last but not least, temperature anomaly forecast in degrees Celsius. We've got some very warm temperatures coming to Pennsylvania, and we'll take it. Did you know that makes for higher average speeds? Yeah, higher average speeds. Why? Because warm air is less massive than cold air, which means the bike just slices through it a little bit faster. Or you could say the less massive air gets out of the way more easily. 72-hour GFS temperature anomaly forecast in degrees Celsius. Or centigrade, if you prefer. Centigrade. I don't find myself able to say that. Degrees centigrade. Okay. Anyway, lots of lightning across Texas for the past 10 hours, as you can see there. As far as real-time lightning maps, we did have some Texan lightning there. Places northeast of Waco. And yeah, that system is expected to move to the east, and that is likely to be a supercell as well. Yeah, that's not looking optimal. Moving right along to this massive band of moisture there. Rain all the way from South Dakota to Maine. One continuous line there. It's a pain when the rain falls on the plain in Maine. Here is the visible satellite. As a low moves across Nebraska, here is the water vapor map. So you can see a blocking feature here of dry mass of air. It's providing some resistance for this chimney of moisture. And there's a compression happening here as well as this dry mass of air impulses. So you're going to have collisions happening here. This is going to become worse and worse. You're going to have severe weather for an extended period, just like the forecast shows. Look at the massive pressure gradients that are going to get created. This is all hot and moist in here already. So there will be lots of convection channels available for recycling of convective energy in the atmosphere. Here's your recap Doppler radar, visible satellite, and the water vapor map. Break that out when your Doppler is unclear, and it often is. The water vapor map. It's splentacular, and I am out of here. In the meantime, may that solar wind be at your back.